All right, so Friday's lesson was on uniform acceleration. Acceleration has to do when there is a change in velocity. So acceleration occurs when is a change in velocity. Okay. Keyword change. And this all occurs with respect to time. So it's important and interesting to notice that acceleration is actually a rate of a rate with respect to time, because velocity is also a rate. So if we take this in words, change in velocity, okay, and this has to do with a change with respect to time. Acceleration is the symbol, A is the acceleration symbol with an arrow on top, which means it's a vector. Change in velocity, change, delta, with respect to a change in time. So this is the general equation for acceleration. So delta V is change in velocity, delta T is change in time, and A is acceleration. So if we take a look at the units for a minute, velocity, one possibility is meters per second, but don't forget it is a vector, so it needs a direction. Time, we'll say it has units of seconds. So if that's true, what are the units of acceleration? Well, on the numerator, it's meters per second with some direction divided by seconds. But as we know in math class, when we're dividing by a fraction, even though this doesn't look like a fraction, every whole number is a fraction. So I have to make the denominator look like a fraction. Okay? So now, when I look at the units, I have to take that denominator and invert and multiply it. So I'm going to invert it and I'm going to multiply. The direction can be taken out side because we're just working with the units. So we're left with meters per second squared, because seconds times seconds is no different than x times x. So the units of acceleration, or a possible units of acceleration, is meter per second squared. There are other possibilities. Okay, don't forget there will have to be a direction because it is a vector. Okay, acceleration needs a direction. It is a vector. But some other possibilities, so we could do meters per second squared. We could do kilometers per hour per second. As long as there's a velocity and then another rate as a time, then that works. And don't forget, it needs some direction. Okay? So pause it here if you need to catch up and copy. So what we're going to talk about now is another version of the acceleration equation. So I'll start with the one from the last page. Acceleration equals delta V over delta T. But what I want to do now is I want to take that numerator and expand it, because we know delta V means change in velocity. Let's take that and put V2 minus V1 all over time. So instead of the delta V, I'm going to take that and interpret it as two different velocities at two different times. You can separate the delta T as well, but often we say an interval of time. So now the equation looks like this. Okay. It's not any different. It's just the exact same one with the numerator expanded into two separate velocities. All right. So the only thing new is that V1 is the initial velocity. And V2 is the final velocity. Okay. Now in some textbooks, you might also see VI or VF. The 1 and 2 just mean two different velocities at two different times. So if you use VI and VF, it just means at the beginning, or the initial velocity at the beginning of the time interval, and the velocity at the end of the time interval. So for final. Delta T still means the time interval. And acceleration is still acceleration. Now, what I want to talk about now is rearranging equations. Okay, so if you need to pause it here, you can pause it and get caught up. But I'm going to rearrange this equation to solve for the final velocity. Okay. All right, so I'm going to rewrite the equation up here. All right, so I want to solve for the final velocity, which is V2. So that means I need to isolate it. And I need to get rid of all the other terms. So the first thing you should note that having some terms on the top, it's like there's a bracket here. So they are together. And you kind of have to think of BEDMAS in terms of when you're rearranging equations. So the first thing I'm going to do, all right, is get rid of this denominator. And how do I get rid of it? I say in my head, what is time doing to the term above? It's dividing. What is the opposite of dividing? The opposite is multiplying. So I'm going to multiply this side by time. Okay? So I do the opposite math, but I have to do it on both sides. And the reason I have to do it on both sides is because of this equal sign. This means this is equal. To keep it equal, I need to do the same thing on both sides. All right? That keeps it balanced. All right, so the reason I do this is so that when I take time divided by time, they divide out and become 1. And that was the whole reason why I chose that. Just like numbers, the same things work with terms. And what I mean by that is 3 divided by 3 equals 1. X divided by x equals 1. Well, delta t divided by delta t equals 1. Okay? So what am I left with? I'm just going to flip these around. A delta t, sorry, my A is messy there, equals V2 minus V1. So now I'm still working at isolating, okay? I want to isolate V2. So that means I want to get rid of negative V1 or the subtract V1. So what is opposite of subtraction? It's addition. And I want to get rid of V1. Whatever I do on this side, I must do on this side. So I can go like plus V1. I don't know where you like to put it, but you just need to add it. Okay, so on this side, negative V1 plus V1, that ends up being 0. And what I'm left with is V2 equals A delta t plus V1. So I can write it this way. Oops, sorry. V1 plus A delta t equals V2. But in math class and in physics, usually the term that we're solving for, we like to have on the left-hand side. But it doesn't matter, really, but it just looks nice. So I can write the exact same thing, V2 equals V1 plus A delta t. Okay, now this is exactly the same equation as over here. It's just rearranged, solved for final velocity. Oh, V2. Oops. So same equation, the acceleration equation solved for v2. Rearranged. And you don't need to do this many steps as long as you understand. I often can skip a bunch of them, but I'm just showing you how to do it. So that's the note on acceleration. Okay, so now for some examples. All right. A ball is rolling. No, a ball is rolling down a hill at 4 meters per second east, accelerates at 2 meters per second squared east. What is its velocity 5 seconds later? So the first thing I like to do is write my knowns with the symbols. Okay, this will help later on when we have more complicated questions and we'll actually have about 6 equations to choose from instead of just one. Okay, so the initial velocity is 4.0 meters per second east. Oh, we actually want to find the velocity v2. Okay, it accelerates at 2 meters per second squared east. We want to determine the velocity 5 seconds later. So that means the time interval is 5 seconds, and we want to find the velocity. So what I do right now is I take a look at my variables, and I take a look at the units, I take a look at the direction, and I want to see first 2 significant figures, 2 significant figures, 2 significant figures, which means my final answer can only have 2 significant figures, okay? And I have them both in the same direction, so that's good. So essentially they're like terms in terms of their direction. And now I'm going to write the equation. I'm solving for v2, so I'm actually going to use the rearranged version because I've already done that. Okay, and you can take that right off your formula sheet that I've handed out in class, or will hand out in class. And put in our variables with brackets. v1 is 4 meters per second east plus 2 meters per second squared east times 5 seconds. Okay, and yes, I wrote in my units. Okay, yes, I wrote in my directions because direction is just like a unit. And yes, I want you to write in your units because let's say something silly like you forgot to write the time in. Okay, you should be able to look at your units and say, wait a second, I can't add meters per second and meters per second squared. That'd be like adding X and Y in math class, and you can't do that. All right, you can't simplify it. I can't say 4 plus 2 is 6. And then what would my units be? You can't. They're unlike terms. So the first term, it ends up staying the way it is because we have to do multiplication first when we do BEDMAS. Okay, and here I have 2 times 5. Multiplication, I can multiply, but let's take a look at the units to see what happens. Meters, okay, nothing happens to that, but there's a second squared on the denominator. So a seconds divided by seconds squared is going to divide out one of those seconds. So I'm left with 10. Okay, I'm left with 10 meters per second east. Because those divide out, but the meters comes along. Okay. All right. And then we can add those terms because now they're like terms. The units are the same, directions the same. We're good to go. 14 meters per second east. Now, significant figures. Let's take a look at that. Okay. When I multiply, I really technically can only have 2 here. I did carry an extra. It happens to be a 0. But in the end, I can only have 2 significant digits. So what I should have here is approximately 14 meters per second east. Is the final velocity after 5 seconds. Okay? So if you need, pause it here and you can catch up. Otherwise, let's move to the next question. Okay? All right, a ball rolls at a velocity of 4 meters per second uphill. And 5 seconds later, the ball is rolling downhill at 6 meters per second. Determine its acceleration. So essentially a ball was going up a hill and now it's going down 5 seconds later. We want to find the acceleration. So acceleration is what I'm looking for. Let's see what I'm given. Initial velocity is 4 meters per second up. Now you're going to have to take those words. I purposely didn't put it like over here in this question. You will have to read the question sometimes and interpret the direction yourself. Okay? The time is 5 seconds. And then later it's rolling downhill at 6 meters per second. So the second velocity, oops, make sure I get that right. It's 6 meters per second down. Now you can use arrows for this if you want. Use up and down arrows, whatever you like. Okay? And if we look at our equation, all over delta t, you'll see there's 4 variables here. So you hopefully have been given 3 and you're finding the 4th, because that's what's going to happen when there are 4 terms. You will know 3 and you find the 4th one. So let's go ahead and put the information in here. Okay, so V2 is 6 meters per second. I can even put a capital D if you want for down, minus 4 meters per second up, all divided by 5 seconds. And hopefully you're like, wait a second, miss, these directions are not the same. Okay, and you are right. They aren't. So they need to be the same to be able to do the math. All right. Now it's up to you which one you want to choose. It really doesn't matter which one you choose. Okay. So let's choose changing to down. So if I change, if I change this to down, that means I need to change this to a negative and put a negative in there. Okay. Because up equals negative down. Whoops. Up equals negative down. All right. So now there's going to be a negative here, and a negative times a negative ends up being positive. So I have 6 meters per second down plus 4 meters per second down divided by 5. Okay. And if I look back over here, I forgot to note my 2 significant figures. 6 plus 4 is 10. Okay. And 10 divided by 5 is 2. But let's take a look at the units. These are the same. So that's meters per second divided by seconds. Okay. And meters per second. We did that before. That's going to be meters per second squared down. So what I'm left with is acceleration is equal to 2 significant figures, 2 meters per second down. Now you might want to know, well, what would happen if I did that the other way? Well, I can take it and show you what would have happened. This 6 down would have become negative 6 up. I'm going to drop off the units just for a second to make sure I have enough space here. Okay. And then I would have had subtract 4. That would have stayed up. And then I would have had divide by 5. So negative 6 minus 4 would have given me negative 10 divided by 5. That would have ended up being the same. But if we look and make it look like this one, what our acceleration would have been is negative 2, sorry, and the direction was up, is negative 2 meters per second squared up. Is that any different? Oops. Let me come up there. No, and it's not any different. What this is saying is the ball is speeding up while going down. Okay, so it's speeding up as it's going down the hill. Or if you're looking with respect to moving up, it's slowing down in the upwards direction. All right, but these both mean the exact same thing. Okay, Ask me questions in the comments. Okay, so our last example is a car that's traveling at 17 meters per second east. Sorry, a car is traveling at 17 meters per second east if it can slow down at a rate of 2 meters per second squared. Okay, how long will it take to come to a stop? So let's see what we have been given here. Okay, we're given the initial velocity because it said it's traveling at 17 meters per second. It won't always be obvious. Okay, and it can slow down at a rate of 2.85 meters per second squared. So right there is my acceleration. Okay, and since it's slowing down, what does that mean in terms of its acceleration? If it means slowing down, then it's a negative acceleration. Okay, slowing down at 2.85 meters per second squared east. All right. And then it says, how long will it take to come to a stop? So how long is the time and come to a stop? So right here is something you will need to interpret that word as a number. So stop means V2 is going to be 0 meters per second. Now technically, yes, it should be a direction. So we'll just put east because they're all east. Don't forget, slowing down is a negative. All right. So our equation, I'm solving for time. I'm going to go acceleration equals V2 minus V1 all over delta t. All right, so how I like to do the question is to solve for time first. So we're going to rearrange this. And how I rearrange this is I want to get this denominator on its own. So the best thing is first get it on the numerator. Okay, so what we're going to do there is we're going to multiply both sides by time. Okay, and you might have heard this nasty term called cross multiply. But what we are going to do is now time is on the numerator, so I want to get rid of the term acceleration. Well, let's divide both sides by a, or acceleration. Okay, so the accelerations end up dividing out on the left-hand side, and the delta t's end up dividing out on the right-hand side, and I'm left with delta t equals V2 minus V1 all over acceleration. And now it's nice, I can put in my variables. Now V2 happens to be 0, okay? So it's going to be 0 minus V1, which is 17 meters per second east, all over the acceleration, which is negative 2.85 meters per second squared east. All right, and then you're going to take this and you are going to put it into your calculator. Okay, so if you put this in your calculator, you get 5.96. 5.96, and you can think of it like the directions divide out, and I'm left with meters per second divided by meters per second squared. So let's take a look at that. Meters per second, but this is a fraction, this is a fraction, so I'm going to have to multiply by the flipped or inverted. All right, and I'm left with the meters dividing out and 1 of the seconds dividing out. And that's good because this is time, so it's good that it came out to be seconds. And I'm going to look and see 2 significant figures, 3. I'm not going to count this because this really wasn't a number in there, it was a word. So my least significant figures is 2. All right, and so I should round this to approximately, this 6 is going to round this up to a 10. So it's going to be 6.0 seconds. All right. And there we go. Okay? Like I said, ask me questions in the comments or in class. Bye.